Morning, my name is Dr. Janardhana Rao. So my topic is operating systems, and inside this I'm going to start operating system design and implementation. So as we discussed earlier, in my earlier slides, I told operating system is a package. So it is there should be a plan and proper plan how to interface with these software in this. As I told, this is your OS. Inside this OS, there are number of programs are there. These programs will work for different operations as the user wants. So first of all, whoever is going to design or preparing the OS, so he has to design. He should have the plan what this OS is going to do, how what type of programs you are going to add. All these things you have to take into considerations. So first of all, there are different types of techniques to design and implement the operating system. Design goals, mechanism, implementation. The first part, the operating system design goals. So what is the goals of this operating system? After making this operating system, what it will do? It is quite complicated to define all the goals and the specifications of the operating system while designing it. So the design changes depending upon the type of the operating system. That is, it is a batch system, time shared system, single user system, multi-user system, distributed system, etc. So for whom we are making this operating system? For a single user or a multi-user or a batch system, and as for that one, we have to design the goals. So if you look at this first one, there are basically two types of goals while designing an operating system. These are what are the user goals and what are the system goals. The operating system should be convenient, easy to use, reliable, safe, and fast according to the users. However, these specifications are not very useful as there is no set method to achieve these goals. So you can understand, whatever the goals we are setting for the user, always user wants convenient way. Convenient, easy use, reliable, safe, and fast according to the user. So next one is system goals. The operating system should be easy to design, implement, and maintain. These are specifications required by those who create, maintain, and operate operating system. But there is not specific method to achieve these goals as well. So as I told earlier, suppose we are going to start an operating system designing or making. So this is your OS. So we write some application program like write operation, read operations, and related to any multi-program operations program, whether it is any Java or C. We will add, after compile of this program, after compilation, whatever the file coming, that file will be added to the OS. There is a systematic procedure to prepare to design the OS. That is operating system designing. So operating system designing is also done by human beings only, the programmers only. So how to design, how we will design, what are applications the user wants, we write this application program, then compile it, and there is systematic steps are there. According to the steps, step 1, step 2, step 3, that as by using these steps, we will add this compiled program to the operating system. It will be one of the program like this. Like this, there will be number of programs added to the OS. So that is called our OSD, operating system design. So in this lecture, we will discuss and what are the steps and what are the types of operating systems where we are already evolved from time to time. So we'll see this. We will discuss the programming part. We will discuss what are the types of operating systems and how they are evolving day to day. So if you look at this now, operating system, mechanism, and policies. So as I told, there is no specific way to design an operating system as it is highly creative task. So whoever is having the talent for designing the operating systems. So he will prepare as per his will and wish, and some part user convenient like this. So that is a creative part, creative task. So there are general software principles that are applicable to all operating systems, because only software people are developing this operating system. So there are general software principles. So when what is the software principles? SRC, the user requirement, or all these things will be considered, and by taking this things into consideration, they will prepare or they will make these operating systems as per the developer convenient by these creativity tasks. A subtle difference between mechanism and policy is that mechanism shows how to do something, and the policy shows what to do and how to do. So the OS will consider how to do, and we have to plan, and policy shows what to do, what not to do. So policies may change over time to time, and this would lead to changes in mechanism also. So it is better to have a general mechanism that would require few changes even when policy changes occurs also. So that is what is operating system implementation. Now, implementation, how we are going to design part. Once an operating system is designed, it must be implemented also, because somebody should use it. That is only implementation. So because operating systems are collections of many programs. As I told, this is a package, you can say operating OS package, maybe Windows or Linux or Unix, same thing. But inside this, there are number of programs. I told, the developer write a program, and this program after compilation, by using the different steps, this will be added to this package. So that will become a internal part of this program, automatically become internal part of OS. This is internal part. Like this only OS is made of. OS is full of programs, bunch of programs. So how this will be developed by the developers, and what the user wants, as for that one, they write the programs and add these programs by using the different steps to the OS package after. So as you know, every day we're getting upgradation of OS, upgradation of C. You see, initially we got the Windows, later on Windows XP, later on Windows 10, 7, 10, 11. Like this is nothing but existing package. We are going to keep on adding the improvements or modifications and modification programs to the OS, so that it will be a upgraded OS. So versions are changing. Versions means we are adding the number of programs as per the user convenient. So in Windows there was no network programs. So later on Windows XP, they added some programs regarding the internet operations. So it is upgradation of Windows. Windows XP is the upgradation of the Windows. So we will the developers keep on adding the programs to the existing version, and they will put it to the upgraded version. That thing. So as I told, operating systems are collections of many programs. So written by many people or over a long period of time. That's what mainly. Operating system is not developed in 1 or 2 days. It is developed by the many people. They write the programs. After compilation, they will add these programs to the package, your OS package. It keep on increasing. So that is all. What are the programs available in the OS? These are all .exe files, .dll files. So sometimes you can see when you installing any OS in your system. So from CD, so there is one. It is copying the files into this desktop. You will find just very fast moving of the .exe, .dll. That means the programs are in the .exe form. That's what mainly you have to consider. Implementation is a process which is the most important for the operating system. So once operating system is made up, then there should be implementation also. So implementation is a very beginning part, and so you can say after designing the OST, you have to implement this one. So we will install in our systems. Now it is running for the user. That is called implementation part. So implementation is a process which is most important for the operating system. So it is difficult to make in general statements about how they are implemented. So earlier they were written in assembly language, but now higher level languages are used. So as I told, this is our package of OS, and we will write, the developer write the program in C or C++ or Java. After compilation, this compiled program is added by using steps. So this what implement. Earlier it is used, they used to write this operating system in the assembly language, zeros and ones. So the compilation is nothing but zeros and ones. So from high level language, they're writing in high level language. After compilation, this program, by using the different particular procedure, we will add these programs to the OS. That's it. So the first system not written in assembly language, was a master control program MCP for Burgos computers. So what are the advantages of the IARE language if you are writing the programs in IARE language? Code is written more fast. It is compact and also easier to debug and understand. The operating system can be easily moved from one hardware to another if it is written in a high-level language. So, a disadvantage of the high-level language: using high-level language for implementing an operating system leads to a loss in speed and increase in storage requirements. So, in modern system, only a small amount of code is needed for high performance, such as the CPU scheduler and memory manager. So, the bottleneck routines in the system can be replaced by assembly language equivalents if required. So, we see for designing the operating system, first we have to see the structure of the operating system. The structure means how these programs are interlinked between one to one. Because when you are writing programs, means simply there is no interconnection between the interfacing between one program and another program, no use. So operating system, all the programs, what are the programs available in the operating system, they will work interlinked or cordially. So one program will invoke another program. Like this, there must be some link. One program automatically invoke other programs. So ultimately, the user requirement should be solved. So for efficient performance and implementation, an OS should be partitioned into separate subsystems. So this is completely OS, but all the programs are there. So we will partition the OS software programs. That's what. So there must be interlink between the one program and another program, so that they will work as a whole when required. Separate subsystems, each with careful defined tasks, inputs, outputs, and performance characteristics. These subsystems can then be arranged in various architectural configurations. So that's what we cannot write OS as a only one main system. So the complete OS is divided into parts. You can say modules or subsystems. So there must be interlink between one sub-module to another module, and each module should be defined what are the specific tasks for that module will do. So we will see the simple structure. So based on this one, layered approach, microkernels, modules, hybrid systems, Mac OS, iOS, Android. These are these types of operating systems. So based on this, how these softwares are interlinked or arranged in a systematic way. So already it is defined. We defined each module what should be done. So like this. So memory management, it will do memory management problem. It will solve the problem of memory management, and like this we will derive the specific module performance and characteristics. So that is a systematic procedure, how we are loading the programs and how these programs will work. We'll see a simple architecture, simple operating system architecture. So when DOS was originally written, its developers had no idea how big and important it would be eventually become. So as we discussed, DOS means disk operating system was originally written. Its developers had no idea how big and important it is would be. So still we are using DOS commands, basic commands, DOS means disk operating systems. So it was written by a few programmers in a relatively short amount of time without the benefit of modern software engineering techniques. It doesn't break the system into subsystems and has no distinction between user and kernel modes, allowing all programs direct access to the underlying hardware. So like this, they were earlier they prepared this operating system, disk operating system. If you look at this diagram, in this diagram, application programs, the resident programs, system programs, and MS DOS device drivers and the BIOS. This is MS DOS layer structure. So if you go for the another type of operating system, the original Unix was used to a simple layered approach, but almost all the OS was in one big layer, not really breaking the OS down into layered subsystems. So one is users, this is users, and shell commands in another layer, and system calls interface to kernel. And these are the system signals, terminal handling, IO system, terminal drivers, and file system, and CPU scheduling, page replacement, demand paging, virtual memory, and this is one subsystem like this. Kernel interface to the hardware, terminal controllers, and device controllers, and memory controllers, physical system. This is traditional Unix system structure. As we know, as I told, this is OS. So the OS full of the programs. Some programs. These are some programs, and these are some programs. These are some programs, and like these programs are like this. They made one package. You can try, or you can say Unix package, OS package, Unix operating system package. So in this one, lot many programs are there. These programs are .exe files, and when you implement regarding implementation, we will install in our systems, and these programs will work or help the user to get the job done by the hardware. So that's what how it is implemented, and laid by structure. How that is structure of the OS. How these programs are being arranged inside the OS. So that's what our main motto. We'll come across the shell programs, shell commands, compilers, and interpreter systems, system libraries in next class or next lecture. So first we'll see the layered approach. The layered approach is to break the OS into number of smaller layers. So as I told, this is OS, and this is one. This is completely. If you consider this is completely AOS. So we will break the OS into number of small layers. Each of these which is rest in the layer below it and relies solely on the services provided by the next lower level. So this is there will be interlink between one layer. This is one software, and this is another software. This is another software. This is like a module. This is one module. So this is one layer type. So this layer will whatever work done. It requires any programs from this layer. There will be link. There will be link provided. That is layer structure. So it allows each layer to be deployed, developed, and debugged and independently with the assumption that all lower levels have already been debugged and are trusted to deliver proper services. So when you add any program or any software to the OS package, so it should be debugged, tested, executed, compiled. That means after debugging only we'll go for compile. Trusted delivery proper services. So that like this we assume each layer is a software, and they are having the independent work, and it is properly debugged and compiled. This program is added to the OS. So the problem is deciding what order in which place to the layers has no layer can call upon the services of the an higher layer. This is the only problem. So layered approaches can also be less efficient, as a request for service from higher level has to filter through all lower layers before it reaches the hardware. The possibly which significant processing at each step, that we have to understand. That is the only problem. So if you understand, the designer should understand while designing the OS. So that is if you look at this operating system, layered operating system, this is your inside your hardware, and this is one layer, this is another layer, this is another layer. So like this. So there will be link between this program to this program like this. Ultimately, we are able to save the program or delete the program, let it be in operation, what we can do. So this is what the layered approach, which is designed in the operating system layered approach. So if you go to next one, the microkernels. What is this microkernels? This is another structure. The basic idea behind microkernel is to remove all non-essential services from the kernel and implement them as a system application instead, thereby making the kernel as small and efficient as possible. So this is microkernel, also an operating system. Mac has come from the microkernel only. The most microkernel provides basic processes, that is memory management and message passing between the services, and not much more. The security and protection can be enhanced as more services are performed under this mode, not kernel mode. Microkernel, this is the most useful for the embedded systems. So system expansion can be easier because it only involves adding more system applications, not rebuilding a new kernel. So Mac was the first and most widely known microkernel, and now forms a major component of the Mac OS. So examples of microkernel is Windows NT, QNX, real-time OS for embedded systems. So this is a microkernel OS. From microkernel OS only, Mac OS has come. So if you look at this microkernel operating system structure of microkernel Mac OS, this is Mac OS structure. So application programs, file systems, device drivers, basic interprocess communication, memory management, CPU scheduling. So if you look at any operating system, all these functions will be there, but the arrangement of these softwares are different. So if you look at this microkernel, it is we are using for the real-time operating systems in embedded systems like this. So this is the only difference. So every operating system will have the same function, almost same functions and more than these functions also. But these are the common functions in this is user mode, and kernel mode. So there also in almost all operating systems will have user mode and kernel mode. But the arrangement between these modules is different. That's it. So this is another operating system structure, modules. So as I told, this is our OS. So inside this one, there are a number of modules created. Module 1, 2, 3, 4, 5 like this. So more modern OS development is object oriented, with relatively small core kernel and set of modules which can be linked in dynamically. So that's what the modern operating system is. It depends on the modules. So modules are similar to layers in that each subsystem has clearly defined tasks and interfaces. So any module is free to contact any other module, eliminating the problems of going through multiple intermediate layers. So that's what advantage in the modern. Suppose this is one module, one module. So this model wants, it cannot go from all through the like this. Directly it can go that module in contact. So because as I explained, this is your OS, inside this one all softwares are there. So we divide the softwares into modules. So in the layered approach, from top to bottom is there, from bottom to top is difficult. That is only for one problem. That is a disadvantage in the layered structure. Whereas this modular structure, any model can approach any model dynamically. Dynamically it is possible. Any module is free to contact any other module, eliminating the problem of going through multiple intermediary layers. That is only advantage of this model. So right now we are using the modular structure of the operating system. So the kernel is relatively small in this architecture, similar to the microkernel. So the kernel doesn't have to implement message passing, since the modulars are free to contact each other directly. Since this is your OS, all the modulars are there. A kernel also small modular. This is a kernel. You can directly contact the hardware, as we explained since beginning. So since in the modular, all are OS only, software only. Okay. So the kernel is a part of OS only, but kernel is module, but it is very small. It is having direct access to the hardware that we already discussed. So this is, if you look at this modern operating system, so this is scheduling, filing, loadable system calls, executable formats, stream modules, miscellaneous modules. This is Solaris, core Solaris kernel. So this is this Solaris loadable modules. So hybrid systems. In the hybrid system, most operating systems today do not strictly adhere to the one architecture, but are hybrids of several. So as you see, the Mac OS architecture relies on the Mac microkernel for basic system management services, and Berkeley socket design OS kernel for additional services, application services, and dynamically loadable modules kernel extensions provide the rest of the OS functionality. This is Mac OS, as we discussed, see graphical user interface. This is application environment services. This is application oriented services. Then your BSD, this all extensible like this kernel environment, Mac, IOKit, kernel extensions. This is a Mac OS structure. Basically, these are all software programs only. But how they interface with each other, that varies from one structure to another structure. This is Mac OS. We have seen this Solaris also. So as we are using our cellular phones, that is Android phone and iPhone. For iPhone, we require a separate OS, that is iOS, and for your Android, that also it requires operating system. Any gadget, it requires some operating systems. So iOS means iPhone software, iPhone operating system. The iOS operating system was developed by Apple for iPhones and iPads. So it runs with less memory and computing power needs than Mac OS. It supports touch screen interface and graphics for all screens. This is your architecture of the iOS. So when you come to know this mobile application development, that time we'll see what is iOS, and this another operating system for the mobiles is Android phones. And for Android phones, we required separate OS. The Android OS was developed for the Android smartphones and tablets by the Open Handset Alliance, primarily Google. Android is an open source OS as opposed to iOS, which has led to its popularity. Android includes versions of Linux, and Android came from version Java, so it uses Java. Linux and Java virtual machines, both optimized for small platforms. Android apps are developed using a special Java for Android development environment. This is our Android operating system structure of the programs, how they are arranged internally. So these are the Google application framework and applications, and your Android runtime environment, and this is your libraries, the Linux kernel. So this is the Android operating system architecture. So we'll see what is the virtual machines. It abstracts the hardware of our personal computers such as CPU, disk drives, memory, NIC, that is not from where you can get the internet connect card, network interface card, etc. into many different execution environments as per our requirements. Each execution environment is a single computer, for example, virtual box. When different processes running in an operating system, it creates an illusion that each process is running and a different process having its own virtual memory. So, with the help of CPU scheduling and virtual memory techniques, users are thus given their own virtual machines, after which they can run any other operating system or software packages that are available on the underlying machine. So what is the advantage of the virtual machines? There are no protection problem, because each virtual machine is completely isolated from each other virtual machines. Virtual machines can provide an instruction set architecture that differs from real computers, easy maintenance, availability, and convenient recovery. So as you know, we are cloud computing and we use virtual OS. So that's what virtual. We'll come to know in the coming classes.
Like, share and subscribe. Hit the bell icon for more updates.